Well, hi, good morning. Thank you very much for coming and keeping me company while I work on this radio. Today is April 21st, and I'm in the phase of replacing the tired capacitors, and there are a few of them in here. And I think today I'm going to go after three bigger paper ones. One here, one right here, and one right down here. And then there's another similar capacitor, a small one that's tucked under here. I might as well do that one at the same time while I'm in that area. So that would be 4 capacitors. I'm going to do what I can today. If I get those 4 done, I think that'd be pretty good. Okay, first capacitor I'm going to go after is right in behind here. And I can pretty much see where one connection is coming through. I think it's this terminal right here. The other one should be straight across on a level. This one. And I don't think it's this one because there are 2 connections very close to each other, 2 solders that come through, one above the other. This lower one, the one above it, the one I want to get to, I think is right beside this terminal here. Let's take a closer look with a closer camera shot. Let's see what we can see. Okay. Starting with the first one again. It's right down this line here. So it's either this one or this one. I think it's probably this one here. So that's one end of the capacitor. The other end, I think, is right up beside this terminal, right there. This is another capacitor I'm bound to replace also. So should I bother pulling it out at this point? There's there's a big capacitor running behind the board here, and then there's a little tiny one down below. It's actually going to be more challenging to get. And there's a schmozzle of wires and capacitors right here, including the one that's shielded, this one here. It's a schmozzle. And these ones really should be replaced too. This one, I would just be a little hesitant on this one. This guy in behind could be replaced. There's 3 right here that could be replaced. But I'm going to go after the ones on the board. Stick with my plan here. Okay, so I need to set a wedge or some tool that I can be prying up on that capacitor. Let's see what I got here. I got something I can kind of, let me go right in through here. Get a hook on it. Okay, that's going to take some fiddling, so I'm going to go ahead and do that. And I think I'll probably end up doing 3 capacitors kind of simultaneously in here. Excuse me. So doing 3 things at once. I have a hard time with 2 things at once. Okay, let's see if I can get one end of this first capacitor out. I have my hook tool here. There's a bunch of strings right in this area, which I do not want to get caught up in. Got a hook on the, whoops, had a hook on the capacitor. Make sure it's what I'm pulling on. Yep. Okay. Here we go. Oh, Peanut, I just spent half an hour with you. I think it's this one. Oh, unhooked. can't go. Oh, nuts. Gosh. That might be the end of this camera. Oh, it's bad. It's really bad. Bad. Reset. Unbelievable. Well, lucky me. So what happened there is my tripod collapsed. One leg came loose, over it went. With the soldering iron in my hand, I can't do much. I had to just watch it fall. One thing it did do is it got my cat the heck out of here. He is long gone. Well, it's amazing what these cameras take, especially when I deliver to them. I just make sure that leg won't do that again. So disappointing. Okay, now what happened to this? Right in the middle of doing something, no idea what can happen next. Okay, here we go again. Got the hook in. Yeah, I bet you the cat won't be back for quite a while. Because the tripod fell right at him. Okay, I've got the lead and the pliers. I should be able to rip this out of the board now. There it goes. There it goes. What do we got left of this one? Here he comes again. Peanut, you come in here. I'm throwing the camera at you. Feels solid, so I don't know what was going on there. 0.22. It's a fairly large one. 500. Unusual shape. But I guess the idea is it takes up less real estate on the board if you make them like this. And if they were just round, they'd just be a little too fat, maybe. Squeeze them in there. Oh, Peanut, really? But now there's a small one I'm aware of, and another large one I'm going to do anyway. So why don't I pull the large one? It's on this terminal right here. Try and pull that one out. The wire sticking straight out now. Nothing in its way. There, got it. Oh my gosh. See how easy it all is? My tool is buried in the end of the capacitor there. Okay, I'm just going to leave the other end in for now to mark its place, and what we want to do is pull out the smaller one that is uncovered back in there. Okay, ready to pull out the small that's what's left of my part of my camera tripod. The tripod couldn't tell you, the camera could, oddly enough. I think the camera would be the fragile thing and the tripod itself would be the not fragile thing. So I pulled one lead up on this capacitor already. Other lead, I'm not convinced I know where it's going. So it's in the thin part right there. That's it. That's the spot. Let's see. As soon as the solder comes free, I should be able to. Yeah, that's it for sure. So out you come. Come on. Out you come. There. So that's 2.5 of them out now. 0.01. 250 volt. 0.01. Is it time to start sticking some in? I have a third one I'm interested in, but it's actually remote to where I'm working. So I should first reinstall the small one with a 0.01 microfarad capacitor. This actually looks to be in pretty good shape. Very good shape. Green dot. What's a green dot doing on there? This is the banded end of the capacitor. It's marking the outside foil wrap that's inside there. What's the green dot for? No, I haven't seen any other green dots. Wait a minute. No, that's not a green dot. I don't know. Probably nothing. Okay, 0.01. I'm going to stick it in there and get that one done. So as it turns out, no surprise to me, these fairly large capacitor here, 0.22 microfarad, I'm out of stock on those. I don't have that. I have some ones that look like this. That's 5 times the size of this guy. And I have a couple of ways I can parallel up some capacitors and get up into this range, but that's a bit of an expense. What I do have is quite a few lower voltage capacitors. So I'm wondering what's going on here. This is a 500 volt capacitor. When I look on the schematic, I can't see why you would need a 500 volt capacitor. And also on the schematic, this one and the other one that's still in the radio here, same as this, they're rated at 250 volts, not 500. So what's up with that? Now I got to make a decision about what kind of capacitor I want to put in there, voltage rating wise. So why don't we just take a peek into the schematic here. Okay, if we look in the parts table, shouldn't take too long to find these two right here. 0.22 microfarads, 250 volt. 146 and 147, only this time it really is 147. Okay, 146, 147. You're looking for those. We will find, I found them both. Here's 147. And 146 is right here. Let me put this up here, right here. So what are they doing that requires a 500 volt rating or a 250 volt rating? It's an interesting question. So come back here. You can see this is the line that's connecting to here. And it's going to one side of the speaker. Notice the other side of the speaker is grounded. Speaker output here. So some of the speaker signal, well, where is it going? Shouldn't it just be going in the speaker? No, there's a thing called negative feedback, which is extremely useful at reducing distortion in these radios. Very, very useful. You just take a little bit of negative feedback, stick it on the grid of the, probably onto this grid, we'll find out soon. And the result is that radio self-controls its own distortion, harmonic distortion and other things. It's very, very effective. Okay, so that's what this is. This is feedback from the speaker. The speaker is running with, I don't know, 5 volts at most. It wouldn't be very much voltage here. Why do you need a 500 volt capacitor? It really leaves me scratching my head why you would want a 500 volt capacitor here. That's 146. If we look at 147, well, it's just further down the line. Here it is here. But it's not even connected to ground. What's it connected to? Well, we can guess this is a tone control. There's a shielded capacitor right here. Perhaps that's that shielded capacitor that I've noticed underneath a couple times. Maybe this is the volume control. If it's the volume control, this is going to go up to the grid of the triode here. That's exactly what this is. So this is the volume control. The entire signal of the radio goes through this capacitor, shielded capacitor. Okay, but there's no voltage in here of any significance. You might have a DC voltage that might develop as much as 15 negative volts here, maybe. Depends what's going on, at the end of all these wires. And in terms of these three actually diodes here. But it's only a few volts. So why the money spent on a 500 volt capacitor here? So we look at these switches. We notice that says B, that says C, that says A. We look over at the switch diagram, the part that's on this page, we see A, B, and C in the words solo, orchestra, and Sprache. I apologize if you're German for that. Sprache de Deutsch, I think speech is what this is. Yeah, I apologize again. That's 2 apologies for one of my attempted German nonsense there. So anyway, that's what this is. These are tone controls. Now you're switching these in and out, and it's switching in and out the capacitor, and this capacitor is just doing things. Okay, well, I don't see why I can't put a 100 volt capacitor in there. I don't see why I couldn't put even like a 30 volt capacitor, or even less, because I think, I can't say I've ever actually measured the voltage across the speaker, but it can't be much. There's something missing here. This radio has there's something missing. It has 2 tweeters. Is that what these are? Is this a tweeter? What the heck is that? That can't be a tweeter, can it? Ooh. It's hooked up to another one. Well, interestingly enough, there are 2 tweeters in this radio. Let's see, these should be hooked up. If they're tweeters, they get a feed off the plate somehow. Why they didn't over here? That's not getting towards the plate. You'd want a plate voltage without any capacitor involved, so it'd have to be on this line. I don't think it's going to get there. What are these? They are hooked up to more B and C, more tone type stuff. I feel like an idiot. When this happens. So here's a hint. That's a phone. These are the jacks on the back. That's what these are. These are the jacks on the back. I'll say it one more time. So this is the probably the tape. It doesn't say, and this is, they put the phono symbol beside this one. So I guess they figure once you see this symbol, you'll then know. You'll know what this is. But if you find this one first, well, tough luck. Okay, so that's what that is. Those are jacks, and they do look like that. They look like that. Interesting, the phono input, well, it's a mono because it only got one speaker, so it's got to be a mono. Only got one output too. Right. So in case you happen to have a stereo cartridge, it's monoized. Okay, I'm totally sidetracked, but I gotta figure that stuff out at some point because Bluetooth may be in the future for this radio. Who knows? Who knows? Back to what I was doing. So I can put those capacitors in. I could always measure the voltage to double check. It just seems ridiculous. I think I'm going to put a voltmeter here and find 300 volts. I don't think that's going to happen. I mean, you literally can't have any big voltage here or it's goodbye to the speaker. Absolutely. Absolutely. Okay, that settles it. Okay, I'm going to pull out that last big one here. I figured out which terminal it is. Just get a grip on it. It's this one here, I think. No, it's not. There it is. This one. There we go. 122. 500, same as the other. Let's test these guys out. See what I'm really pulling out of this radio. These are the replacements here. Some orange drop styled ones. This is what I want to bring over. We'll try this little guy first, which he looked okay. Okay, eye on the eye. Opened almost all the way. Bet you it won't open now though. With 150 volts and it doesn't open. It kind of gives me a bit of a quantitative way of judging these. How high you can go here with the voltage. Seldom can you get above 150. Or in other words, at 150 the eye fails to open on almost all these old capacitors. Okay, next guy, 50 volts. What do you say? Let's give it some time here. It's open a little wee bit. Bigger capacitors, more surface, if you like, to have a leak, have leakage take place. There's just no way it's going to open on it. This. Okay. Set it aside. Maybe it's still charged. Okay, 50 volts. It's not going to open at all. Bad guys. These are bad guys. Now these are located in the feedback circuit. Depending upon how bad they are, what would that do? You just have to assume reduction in capacitance would be a reduction in the amount of feedback coming, and it will also alter the phase angle, maybe a little bit. I don't know. An increase in leakage. I don't know. I mean, in the speaker circuit itself, there's lots of juice there. So a little leakage through a resistor or a capacitor is not going to do anything to the speakers. But I think the manipulating the feedback incorrectly would give you maybe poor tone response. Maybe the treble would disappear. I don't know. You wouldn't get what you're supposed to get. That's what I think. Okay, so I'm going to put these two in, and we'll give the. I have one more I wanted to get at before we try the radio again. Okay, I've got my fourth target capacitor for today out. 0.1 microfarads. You know, this one looks really good. This looks, I don't know if they can look much better than this. So interesting to see what happens. We'll put it on the tester. Give it a go. I'll just come on over here. My guess is it'll just be the same as the others. Just trying to get the eye to show up a little bit better. Can't really do it. Okay, here we go. 50 volts. What do you say? And it's not opening. So this is actually an indication of a serious leak, I guess you could say, especially in comparison to all the capacitors that I regularly test. How bad can that really be? Well, what happens if we just try to measure this with just a regular ohm meter? Excuse me. But better than that, I've got the Allen meter here. Just my pet name for this meter. What I would expect from my experience, you really won't be able to read anything other than an open circuit. Let's see. This one goes all the way up to 60 megohms. Let's start at 6. Okay, 60 big ones. Don't think I've ever had an ohm meter that could read that high. Yeah, so we're finding nothing out here. And now, just for fun, 600 millivolts. See, that was for fun. Okay, so somewhere in there was some fun. I'll have to explain myself another time. Okay. But it's all interesting. Because often, you know, you get stuff you don't expect. You take a measurement, you get a result you don't expect. And that's kind of fun. Okay. So I just need to replace that capacitor, and we're ready to test this radio again. Okay, time to give this guy a try. Okay, let's see what's happened here. Right. Okay, let's try that again. This time I've got it plugged in the back for power. It's off. There we go. Good. See the magic eye coming on. Staticky AM again. FM. Okay, the main thing is it's working. May not be working all that well just yet, but that's probably an alignment or tuning issue, or the tuning can box is still apart. But at least it's functioning pretty much the same as it was before I did the capacitor work. A little bit better? Well, sure. Okay, so thanks for watching, and tomorrow a little more of the same.